currently a senior informatics scientist at the Pacific Northwest National Laboratory. I'm a class of 2008 UCSD PhD student and a class of 2002 Brigham Young University Bachelor's in Computer Science. So my current research has two areas. I have one part of my research is on integrating omics data, proteomics data, and metabolomics data with larger genomics data sets or transcriptomics data sets. The second part of my research is an emerging area for me, is working on adapting principles of computer science to data analysis, so making data analysis a more formal or rigorous process. No, during my undergraduate, bioinformatics as a degree did not exist. So when I was an undergraduate student in about 2000, my sister recognized my interest in biology and my skill set in computer science and said that there was an emerging field called bioinformatics, but that there was no real degrees in it yet. So I kind of chose courses in my undergraduate that I thought would prepare me for being a bioinformatics researcher. So I love bioinformatics. That's the real first reason. I really enjoy genetics and microbiology. I think those are very fun topics. My skill set in computer science leads me to blend those two. My sister introduced me to the topic. I think that's a really important thing. I did an internship as an undergraduate at the NIH, and although it was in a topic that is entirely unrelated to what I do today, I think the internship was very valuable for me to see what science is, and it was also valuable to me as a resume bullet because it showed that I had initiative to do something with my interests. When I first found out about it, bioinformatics was very much about microarrays and structural biology. I think as technology's changed, bioinformatics as a discipline is less about a specific technology and more about the idea, which is what they tried to teach me here at UCSD. What they wanted us to focus on was the ideas, but in practicality it was a very narrow domain, I think. As I said, I think one of the ways it changes it is that it becomes more general and less about a specific technology. I believe it also is becoming more standard in its use in most projects. As technology advances and people get lots of data, data processing and data analysis is simply part of the workflow. And so bioinformatics, whether called bioinformatics or called something else, I think dealing with data for biology is becoming a regular part of everyone's life. So my research, as is it's supposed to be, changes as new topics become important and old topics become kind of settled. So as someone gets better and better at a topic and that field doesn't stagnate, that's probably the wrong word, but that as that field kind of moves on its own, new topics come up and new fields come up. The issue of collaborative data analysis and visual data analysis is for me a very new field for bioinformatics, and that's exciting to me, and so that's a change. And I hope that over the next many years there will be new changes that I get to be part of. For me personally, I think a trend that is important is gaining meaning from data. I think the last 10 years or 15 years of bioinformatics has been about getting data. This can be seen in the NIH's focus on big data to knowledge, and many other agencies have a similar push. I think getting meaning from data is an important new and emerging area so that we show value, we discover things, not just amass data. So part of the thing about bioinformatics that I really enjoy is the opportunity to be a part of many different groups. In my research at PNNL, I work with ecologists, I work with geologists, I work with people studying microbial communities over time. I work with people studying infection. I work with people studying specific diseases. All of that is something for me to learn, and I really love learning. I think the computer science side has a lot of people pushing it in a direction, and as a bioinformatics person, you're fortunate to be able to pick certain new algorithms or new ideas out of computer science that are really useful for biology, and so you get to have the best of both worlds. I don't think it's at all unique, but I think the most challenging part is keeping up with everything that's being done. There are a lot of wonderful scientists doing really exciting research, and it's hard to keep track of everything. So one general advice would be do your best to get an internship and get some experience. I think that will help you understand whether you like science as an idea and science as a job. I love it, but maybe not everyone does. It is hard, and for me there was a big kind of aha moment when I realized that jobs are not like school. There is not a correct answer that we can find and call finished. Jobs are about solving challenges that no one has yet solved. And that is a difficult change in how you approach your work, which is why I suggest that you be part of a research experience as an undergraduate student, so that you can get used to that and it won't be as jarring as it was for me.